In the second recording on Surds, we'll be looking at rationalising the denominator. So hopefully you've already watched the first recording on Surds, which just looks at the rules of Surds and manipulating Surds. Okay, how do we rationalise the denominator? As it suggests, we need to turn the denominator into a rational number. At the moment, root 3 is irrational. How do we make it rational? Times it by itself. Now, we're changing this fraction into an equivalent fraction. So it's the same rule as when you are multiplying by a non-surd. Because we're multiplying the denominator by root 3, we also need to multiply the numerator by root 3. So let's look at this numerator. 2 times root 3 is just 2 root 3. Root 3 times root 3 would be root 9. I wouldn't necessarily write that step down. If you're timesing something absurd by itself, it just becomes 3. So just get into the habit of, well, what's root 5 times root 5? 5. Root 3 times root 3, 3. Why? Because root 3 times root 3, we can multiply the 3's together, which gives us 9, and the square root of 9 is 3. It's because the squaring of it reverses the square root, if that makes sense. Okay, so maybe have a go at rationalising these denominators. Put me on pause and pause when you're done. So let's multiply the denominator and the numerator by root 7. 5 times root 7, 5 root 7. Root 7 times root 7, 7. So this time, well, what you could have done perhaps is multiplied by 3 root 5. I will show you what would have happened. Well, yeah, in fact, let's do that and we'll look at the other case in a minute. So if you multiply the numerator by 3 root 5, 2 times 3 root 5, 2 times 3 is 6, we've got 6 root 5. 3 times 3 is 9. Root 5 times root 5 is 5. 9 times 5 is 45. This simplifies. Common factor of 6 and 45 is 3. So divide the numerator by 3. We get 2 root 5. Divide the denominator by 3 and we get 15. What you could have done perhaps is multiply the denominator and numerator by root 5. Let me just show you that over here. And it would just mean we get the same answer, we just wouldn't have to simplify at the end. My idea would be, well, I just need to make this rational, so just times it by root 5. Okay, root 5 times root 5 is 5, times 3 is 15 for the denominator. And for the numerator, 2 times root 5, 2 root 5, which is the same as we got here. Just make some space on my board and we'll look at these last two questions. So let's rationalise the denominator here. Multiply by root 6, multiply by root 6. Root 2 times root 6 is root 12. Can actually simplify that, I'll come back to that in a minute. Root 6 times root 6 is 6. So don't forget, always look, can I simplify? Root 12, right? 4 is the highest common factor of root 12, right? So I can make that into 4 times 3. Square root of 4 times the square root of 3. Square root of 4 is 2. 2 root 3 over 6. You can simplify 2, 6 by dividing them both by 2, which should give you root 3 over 3. I'm going to multiply the denominator by root 3 and the numerator by root 3. 3 root 5 times root 3. Well, I can multiply the root 5 by root 3 which gives us root 15. Root 3 times root 3 is 3. 3 divided by 3 is 1, cancels out, so the answer is root 15 there. Okay, this is the highest level of surds you are expected to know for the higher paper. So how do I rationalise the denominator here? So what I need to do is multiply by, it's kind of the same thing, but instead of a plus, we have a minus. I'll show you why that works in a minute. Because I'm multiplying the denominator by root 3 minus 2, we're also going to multiply the numerator by root 3 minus 2. I've just put it in brackets here. Maybe I'll work it out. Right, we'll do the denominator first. I'll kind of do this as an aside so you can see why it makes the denominator rational. Root 3 times root 3, 3. Negative 2 times root 3, negative 2 root 3. 2 times root 3, 2 root 3. Positive 2 times negative 2. Positive times negative is negative. 2 times 2 is 4. Right, let's simplify. 3 take away 4 is minus 1. As you can see here, minus 2 root 3 plus 2 root 3 is 0. So it cancels out. So our denominator is minus 1. Let's check out the numerator. Eight times root 3, 8 root 3. 8 times negative 2, negative 16. If we did want to divide them both by minus 1, we'd have minus 8 root 3 minus 16 divided by negative 1 is positive 16. That's just to really just tidy it up. Maybe if they asked you to simplify it fully. I'm going to do one more example before I set you off on some questions by yourself. So what are we going to do here? Well, we're multiplying it by the same expression. Instead of a minus, we always have the opposite sign in the brackets to make the roots disappear. This time the opposite sign of minus is a plus, but I need my 5 and need my root 3. Okay, let's multiply, expand the brackets on the numerator. 9 times 5, 45. 9 times root 3, 9 root 3. Right, I'll do the bottom, the denominator here. It's got 5 minus root 3 times 5 plus root 3. 5 times 5, 25. 5 times positive root 3, 5 root 3. Negative 3 times 5, negative 5 root 3. Negative root 3 times positive root 3, negative 3. Simplify, 25, take away 3 is 22. 5 root 3 minus 5 root 3 cancels out, 0. So that is our answer here. Just to check if you can simplify, look at every term, every number. Do they have a common factor? Well, 45 and 9 do, 3, but the 22 doesn't. So no, we cannot simplify. Okay, maybe have a go at these 3. Put me on pause and pause when finished. So for this top one, I'll do them all on separate pages. The minus needs to be a plus. Everything else stays the same. Because I've multiplied the denominator by 3 plus root 2, I also need to multiply the numerator. Numerator, 6 times 3, 18. 6 times root 2, 6 root 2. And the denominator. Let me just do that separately. 3 times 3, 9. Plus 3 root 2. Minus 3 root 2. Negative times positive, negative. Root 2 times root 2, 2. 9 take away 2, 7. 3 root 2 minus 3 root 2 is 0. So this is your final answer. Middle one. So I'm going to multiply the denominator by 1, take away root 5. Same with the numerator. For the numerator here, 4 times 1 is 4. 4 times root 5, 4 root 5. On the denominator. One times 1 is 1. Minus 1 root 5. Plus root 5. Positive times negative is negative. Root 5 times root 5 is 5. Then we have 1 take away 5 is negative 4. And minus root 5 plus root 5 cancels out. Now let's just divide everything by negative 4 to simplify. Because as you can see, 4 is a factor of all of them. I want to be left with nothing on the denominator. So 4 divided by negative 4 is negative 1. Negative 4 root 5 divided by negative 4 give you positive root 5. And then question 3, we need to multiply the denominator by root 3 plus root 2. And the numerator by root 3 plus 2, root 2, sorry. The numerator, 8 times root 3, 8 root 3. 8 times root 2, 8 root 2. The denominator. Root 3 times root 3, 3. Root 3 times root 2, root 6. Minus 2 times root 3, minus root 6. Negative times positive is negative. Root 2 times root 2, 2. 3 take away 2 is 1. Root 6 minus root 6 cancels out over 1. And if it's over 1, it's just 8 root 3 plus 8 root 2. Okay, just 3 more questions for you to look at. You may feel more confident with these now, but it'd be good to practice a few more. So again, I suggest maybe having a go at them yourself, put me on pause and pause when completed. Multiply by root 6, add 3, and the numerator. Okay, so 3 root 6 times root 6. Well, root 6 times root 6 is 6, times 3 is 18. And then 3 root 6 times 3. 3 times 3 is 9. It's 9 root 6. And the denominator, root 6 times root 6, 6. Root 6 times 3, 3 root 6. Minus 3 root 6. Negative 3 times positive 3 is negative 9. Let's just simplify the denominator. Cancels out. 6 subtract 9 is negative 3. I've just spotted here that all of these have a common factor of 3. But I don't really, so I'm going to divide everything by negative 3. So I'm not left with a negative 1 as the denominator. 18 divided by negative 3, negative 6. 9 divided by negative 3, negative 3. Question 2. Okay, so for this next question, we're going to multiply the denominator by 2 root 3 minus root 5, and the numerator by the same thing. Numerator, pretty straightforward. 1 times 2 root 3 minus root 5 is just 2 root 3 minus root 5. And the denominator, 2 root 3 times 2 root 3. Well, root 3 times root 3 is 3. 2 times 2 is 4. 4 times 3 is 12. 2 root 3 times negative root 5 would be negative 2 root 15. Because I can multiply the root 3 by the root 5. Root 5 times 2 root 3. Well, root 5 times root 3 is root 15, so 2 root 15. And root 5 times negative root 5 would just be negative 5. Cancels out. 12 take away 5 is 7. So my final answer I will write over here, 2 root 3 minus root 5 all over 7. Okay, and this last one, we're going to multiply the denominator by 1 plus root 5, and the numerator by the same thing. Let's deal with the numerator first. 1 times 1, 1. 1 times root 5 plus root 5. Root 5 times 1 is 1 root 5. Root 5 times root 5, 5. Denominator, 1 times 1, 1. 1 times root 5, root 5. Negative root 5 times 1, negative root 5. Negative root 5 times positive root 5. Negative times positive is negative. And root 5 times root 5 is 5. These cancel out. So on the top we have 6 plus 2 root 5. And the denominator, 1 take away 5 is negative 4. Let's just simplify that by dividing everything by 2. And the reason I divided everything by 2 is all of these have a common factor of 2.